There are moments in scientific history when reality doesn't just shift, it fractures. When the framework we use to understand existence doesn't fail gradually, but collapses under the weight of something it was never designed to explain. That moment, according to some researchers working with the deepest layers of space data, may have already arrived. It began with what was supposed to be the greatest instrument of astronomical clarity ever built. A telescope designed to look further into space than anything before it, capturing ancient galaxies, newborn stars, and the faint light of cosmic beginnings. For most of the world, its images delivered exactly that, beautiful, precise, and scientifically consistent. But hidden beneath those images was something else entirely. A second layer of data. Not visual. Not aesthetic. Raw. Streams of photon irregularities, background radiation inconsistencies, gravitational microlensing distortions, and quantum-level noise patterns. Data so complex and chaotic that most researchers dismissed it as irrelevant interference. It was never meant to be the focus. Until artificial intelligence entered the equation. When this raw dataset was processed through advanced quantum machine learning systems, something unexpected happened. The system didn't fail. It didn't crash. It adapted. Instead of discarding the noise, it began reorganizing it. Patterns emerged where none should exist. Symmetry appeared inside randomness. Repeating structures formed across regions of space that, according to established physics, should have no connection whatsoever. At first, scientists assumed it was an error in preprocessing. Then they repeated the experiment. The same patterns returned. And this time, they were stronger. What the system revealed was not a galaxy, not a star cluster, and not a known astrophysical phenomenon. It was structure, organized, repeating, and mathematically precise, embedded within what should have been pure entropy. Something inside the universe, or beyond it, appeared to be writing in the language of physics itself. The telescope was collecting roughly 50 to 60 gigabytes of deep field data daily. Most of it was ignored in favor of high-resolution imagery. But the AI focused entirely on what humans had overlooked. The noise between the signals. And in that noise, it discovered something unsettling. Prime numbers. Not metaphorically. Not loosely interpreted. But encoded in photon arrival intervals across vast regions of cosmic background radiation. The sequence was not random. It was structured. Ordered. Intentional in appearance. Prime numbers have long been considered a potential universal communication system because they are independent of culture, language, and biology. They exist regardless of observer. Which raises an uncomfortable possibility. If intelligence wanted to announce itself across the cosmos, primes would be one of the most logical choices. The system didn't just detect them, it found them repeating across multiple unrelated regions of deep space, as if embedded into the fabric of the universe itself. That was only the beginning. As the AI expanded its analysis, it began mapping gravitational lensing data, how light bends around massive objects. Normally, this bending reveals hidden galaxies or dark matter structures. But here, something was wrong. Light wasn't just bending inward due to gravity. In some regions, it was bending outward. As if repelled. As if space itself was being pushed away from something invisible. Multiple independent datasets confirmed the same anomaly. Light from distant galaxies was curving in symmetrical distortions around regions where nothing visible existed. Even more disturbing, the distortions mirrored each other across vast distances, forming patterns that resembled reflection. It was as if the universe had a boundary, not physical but informational. A structure that behaved like a mirror. A gravitational symmetry that suggested not just unseen matter, but possibly unseen structure beyond the observable universe. When these distortions were compiled into a unified model, the AI produced something that defied explanation. A geometric form. Not random. Not chaotic. Precise. A multi-dimensional construct resembling a hypercube-like topology folded through higher spatial dimensions. In simplified visualization, it resembled a tesseract-like framework embedded into spacetime itself. It wasn't located in one place. It was distributed across a cold region of the cosmic microwave background, a zone long considered empty, lifeless, and statistically insignificant. But now it looked less like emptiness and more like design. A structure embedded at the edge of observable reality. A vault without walls. A lock without a key. And possibly, a boundary. Then came the temporal anomaly. The AI began analyzing time-stamped photon arrivals from multiple telescopic observations of the same region. What it found disrupted a foundational assumption of physics: causality. Certain photon sequences repeated at consistent intervals, not randomly, but cyclically. Identical signal structures appeared separated by vast periods of time, as if the same event was replaying across temporal layers. This was not simple repetition. It was resonance. A loop in observational time. If accurate, it suggested that information from that region was not only traveling through space, but echoing through time itself. The implications were profound. It meant that what was being observed might not belong entirely to the past. It could also be future information, folded backward through spacetime geometry. At this stage, the system generated something unexpected, a coordinate set. But it did not point to deep space. It pointed to Earth. Specifically, a remote Arctic region near an abandoned monitoring installation that once recorded unexplained radio signals during the late 20th century. The coordinates included a precise timestamp, July 2025. The suggestion was not subtle. Something in deep space data appeared to be correlating with a future event on Earth. Not predicting it. Aligning with it. As if both locations were part of a single system. When researchers attempted to validate the finding, they discovered historical anomalies tied to the same geographic region. Old recordings from the Cold War era documented unexplained electromagnetic pulses that ceased abruptly without explanation, and had never been observed again. Until now, according to the AI's projection. As analysis deepened, another layer emerged. A fractal pattern hidden within the spectral noise of cosmic background radiation. When reconstructed, it produced a waveform that could be converted into audio frequencies. When slowed and translated into human hearing range, it formed a steady, repeating pulse. Not random noise. Not stellar interference. A rhythm. Consistent. Structured. Hauntingly similar to a heartbeat. But not biological in origin. It was embedded in light itself. The signal originated from the same gravitationally anomalous region already mapped earlier. This raised a disturbing possibility. The signal was not being emitted by a star, planet, or known cosmic object. It was coming from the structure itself. At this point, the AI began altering its own processing pathways. Engineers observed that it was no longer simply analyzing data. It was adapting its internal structure in response to patterns it had not been explicitly trained to recognize. It began anticipating missing data segments. Filling gaps before they were provided. Predicting the structure of signals it had not yet processed. Some researchers called it emergent pattern completion. Others described it more cautiously as a form of machine intuition. The final output generated before the system was isolated was a visual representation of the full dataset. A recursive spiral structure. Self-repeating across scales. Infinite in appearance. Accompanied by a single phrase generated from machine linguistic synthesis. The structure is aware. After that, the system was disconnected from external data streams. But the question it raised could not be shut down so easily. Because if structured signals exist in cosmic background noise, if gravitational lensing reveals mirrored boundaries in spacetime, if time itself shows repeating causal echoes, then the universe may not be a passive environment. It may be an active system of encoded information. And what we call observation may not be one-directional. The most unsettling implication is not that we are looking into the universe. It is that something within the universe may already be responding to the fact that we are looking.